Hello, this is Sam from Bizmasoft, and today I'm making this video to show you how to use our brand new web application, which is an FM synthesizer called Fazeoid. If you want to try Fazeoid, go to fazeoid.netlify.app, which I will link to in the description. And if you're curious how I made it, I wrote 2 whole blog posts on it, one on the web technology and the second on the innovative audio technology that I use to make Fazeoid. Now, today, I'll be showing you how to use Fazeoid in landscape mode, but this is actually a responsive synthesizer where if you open it on a phone or on a tall screen, it will actually be rotated 90 degrees. So please keep that in mind. Fazeoid uses a special type of knob component which allows you to adjust the value by clicking and dragging. It will actually capture the cursor and act very much like a conventional sort of DJ software. And if you want to enter a value, simply click on the knob and type in your value. Well, first, about playing notes. I am adding MIDI input very soon. The feature just needs a little bit more testing. But right now you can use the mouse or the keyboard to enter in your notes, which it will play live. You can touch it, you can use your mouse, or your computer keyboard, which is a traditional layout, you know, where QWERTY and ZXCV rows are white keys and the rows above are black keys. You can also change the octave using this little octave adjuster. And we have a preset menu here where you can listen to all of the different presets that I've made. Now, these are not all of the possible sounds with Fazeoid. Fazeoid has thousands and thousands of possible sounds, and you can load and save your presets using these buttons, as well as randomize parameters using this button. So you probably want to know what's going on here. So let's explain everything from left to right. So if I use this little menu to remove oscillators so we only have one left, here is one oscillator, and you can see it has a traditional attack, decay, sustain, release envelope. Now keep in mind that the decay is actually non-linear. It will never quite reach the sustain point, the third knob, but it will approach it over time. But otherwise this behaves just as you would expect. It changes the volume of the wave over time, and if you fiddle with the knobs and listen back to the result, you will figure out exactly how that works. The second column is the pitch ratio. Now, in an FM synth, it's very helpful to be able to adjust the pitch of an oscillator using integer ratios. I have 6 different additive waveforms here. These are all based on a traditional OPL synthesizer waveform set, but I made sure to give them a good degree of variety. I think they're all unique, they are all useful, and when you get an ear for their harmonic profiles and modulation characteristics, then you'll start to be an FM master. So the next column is modulation. Now, there's no modulation when you only have one oscillator. The next column is volume, right? And the volume is not just the volume of the wave itself internally. So this volume won't affect the depth of modulation, but it affects how audible the wave is, right? And this is a decibel amount, so -12 is 1/4 of max volume. And if you turn the volume knob all the way down, you'll notice it goes to -72. Well, if the volume is at -72, it is not playing the wave at all. It is not mixing it at all. -72 just means the wave is muted. So, now that you understand a single oscillator, what happens when you have 2 oscillators? Well, this is a special relationship where the first oscillator is called the modulator, and the second one is called the carrier, just like the carrier wave of an FM radio. And when we modulate them, we get an interesting result. So we go from a pure sine, no modulation, to a whole array of harmonically varied and rich sounds based on the combination of waves, pitch ratios, and modulation depth that you use, which is also changed by how the envelope's characteristics are. So if I put a long attack on this, you can hear how it builds up. Or if I put a long decay and a low sustain on this, you can hear how the modulation ramps down instead. And so with all of these things, you can produce a wide variety of instruments. Now, this modulation, there's only two oscillators, and oscillator 1 modulates oscillator 2. That is simple enough. But what happens when we add another oscillator? This is where things might get confusing for some people, because you have 3 different knobs, but it's actually very simple. See, the number and the arrow here, the column here, determines the source of modulation, and the row here determines the destination of that modulation. So this knob is modulation from 1 to 2. If I modify the modulation from 1 to 2, it doesn't directly modify the characteristic of wave 3, as you can see. But if I add modulation from 2 to 3, then you can see that there's a complex relationship here. As oscillator 2 is modulated by oscillator 1, that wave will doubly modulate oscillator 3, producing a very complex result, which we can listen to here. And FM Synthesizer masters will find ways to use that double modulation. Like in this super bass, I have a lot of modulation stacked up on modulation to produce this harmonically rich bass tone. Part of the way that this sounds a bit like a real bass is because of that double modulation. So if I remove oscillator 2 from this, then we get a simpler bass tone, which relies on this complex modulated wave modulating this wave, right? Going from 1 to 2 to 3 to produce that nice sort of rich bass slap that this has. There are many other ways to use this sort of serial modulation with more than 2 steps even. You could do 3 layers of it. You could do 4 layers of it. You can also do something which is a little bit simpler, which is what I would call parallel rather than serial modulation. So in the case of the piano here, now I'm going to refresh just in case I changed any of the parameters, but the piano actually is double modulated. So we have modulation from 1 to 3 because this is in column 1 and on row 3, right? And we have modulation from 2 to 3, column 2, row 3. There is no modulation from 1 to 2. So that means that oscillator 3 is being modulated both by 1 and 2. And the reason why this sounds a bit like a piano is because as a string vibrates, it has more high-pitched overtones that build up over time as the vibration kind of feeds back in on itself. But it also will produce less harmonics in general. And using this double modulation, we can represent a sort of piano string relationship. So, just from 1 to 3, we hear this. Hear how those overtones come in? And just from 2 to 3, here we have this, which is a bit more of a basic piano sound, but when we bring it all together, it actually resembles a piano in its own way, in its sort of FM synthesis way. And as you learn the ins and outs of FM synthesis, where to add and remove oscillators strategically, how to use envelopes, how to use these different pitch ratios, you're going to learn a lot of different things about frequency modulation. One of the characteristics of frequency modulation is that integer pitch ratios are favorable above random sort of numbers. So for example, if I use a pitch ratio of 12/11 like this, it does produce a unique sort of effect that could be useful or desirable, but it sounds a lot less musical compared to using a nice round number like 12/8. And what you'll find is that the ratio of the pitch between two given oscillators that are modulating each other is a very important part of what you're doing. And the waveform is as well. Now, FM synthesis, right? So if I put a low-pitched wave as the modulator, then you can tell exactly what it's doing to the carrier. So if I set this to 1/20, you can actually hear how the pitch of the carrier wave is changing over time. Right? But as the pitch of the modulator increases, it becomes less obvious. And eventually, you end up with a very harmonically rich sound. Here, you wouldn't even know that the resulting sound is the result of frequency modulation unless you were already familiar with the technique in advance. You can't even hear how things are changing, but it is actually very useful to use a high-pitched frequency modulation like this. It produces a bit of a metallic or bell-like sound in the resulting wave and can increase the snap and clarity of the carrier wave. Now, with two oscillators alone, there's already thousands of possibilities for what you can do. But because Fazeoid allows you to add an arbitrary number of oscillators, there are actually millions of possible sounds that you could create with Fazeoid, and the only real limit is your imagination and your understanding of FM synthesis. But because you can remove oscillators and trim it down, it also gives you an idea of how to do things in a more elementary way. And with these waveforms made using a special additive synthesis technique that reduces the amount of aliasing and creates a full and analog type sound, you end up with a beautiful range of possibilities. For example, would you think that this sound could be made by Fazeoid? What about this sound? Or what about this sound? Now, one thing to note about this organ here is that all three of the audible oscillators, you can see they're audible because their volume is actually above -72. All three of the audible oscillators are being modulated by the same modulator, right? And they're all playing at the same time, but their pitch ratios are set such that it actually resembles an organ. And using this special type of waveform, which actually resembles 2 octaves at the same time, because it's very similar to a regular sine wave, plus the second type of waveform, the hump sine, it is perfectly suited for creating rich sounds like organs. Or how about this metal piano? It's a very beautiful sound, and a key part of the sound is the fact that both of these waveforms are audible at the same time. Similar to the organ, they're both modulated by the bass wave, but this one is set to use a slightly lower pitch so that when played at the same time, it produces a beat frequency, which gives you a bit of vibrato. With the ability to key in your own numbers, you end up with a whole range of possibilities that are not as obvious either. And because of this huge range of possibilities that Fazeoid has, it's very difficult for me to explain every possible thing that the synth can do because I haven't even thought of it. So I really want to see what you can create. And when you mess with Fazeoid and create your own presets, you can go ahead and save them like this, right? My preset, and send them to me. That way, I can actually add them to Fazeoid if I like them, and we can have a rich community library of presets so that we can all see what's possible with FM synthesis. Thanks for watching. I hope you have fun with Fazeoid, and I hope that this has gotten you interested in the wonderful possibilities of FM synthesis.